All right, so this is the physics review, AP physics review. So number one is a fairly simple question. You just need to know V equals position over time, or change in position over time. And so we know that the car is going 6.3 meters per second, and it is going a distance that is unknown, a position that we don't know yet, and it's going that way for 8.5 seconds. So if you multiply 8.5 up out of the bottom times 6.3, sorry that looks messy, but you know what I mean, that would be 53.6 meters, and that would be your answer. Number two parts. A jet travels 480 meters per second. How long does it take to travel 200 meters? So first one, distance equals 200 meters. Second one, 9.4 kilometers. So we've got to convert that into meters, and it's 9,400 meters. So V equals position over time. Remember, position and distance will be roughly equivalent unless I make the distinction. So we would do 480 equals 200 over t. Multiply t up, and then we would get 480 t equals 200. Divide by 480, and we would get t is equal to 0.42 seconds. On this one, the second one, we're going to start from this point right here, right? Because it's the same thing. We just changed the distance. So we're going to do 480 t equals 9,400, and then divide by 480, and we get t is equal to 19.6 seconds. Next up, number three, you run 100 meters at 10 meters per second, and then you walk 100 meters at 1 meter per second. What is your average speed? Remember that average speed or average velocity is change in position over change in time. Dadgummit. There we go. And what that means is we have to figure out the change in position. So what is the change in position? You are going 100 meters, and then you go another 100 meters. So how far did you go? You went 200 meters. Okay. Now what about time? Well, you have two different times, time for the first leg and time for the second leg. If you went 10 meters per second for 100 meters, then you went 10 seconds. So that took you 10 seconds. And if you went on 1 meter per second for 100 meters, that's 100 seconds. So your delta t would be 110 seconds. So 200 divided by 110 equals 1.8 seconds. Or sorry, meters per second. All right, so that's number three. What about number four? Car travels 60 miles per hour for 2 hours. So on the first leg, he went 60 miles, 2 hours, 60 miles per hour for 2 hours. So he went a distance of 120 miles. For the second leg, he went 30 miles per hour for a distance of 1 hour, or for a time of 1 hour. So that's 30 miles. All right. At this point, you need to figure out what your delta x is, which would be 150 miles. And you need to figure out what your delta t is, which would be 3 hours. So your average velocity, there we go, average velocity should be 150 over 3, or 50 miles per hour. All right, next up, let's take a look at number 5. Number 5 says describe the motion in represented in the graph above. For A, it is just constant speed. That is the motion. It's going at a constant speed. The second question says what is the slope? What was the average speed? Remember, average speed on a graph like this, V average, is the slope in this particular case, because it's just a straight line. So we would pick 2 points, which would be 0, 0, and 30 and 6. So 30. So you would do 30 minus 0 over 6 minus 0, and you would get 5 meters per second. That would be your slope, and your speed. And the last one says write an equation. Well, remember the equation should be dependent equals independent times the slope. So it would be x equals 5 times t. Okay? That's how that equation would look. Number 6. The image of a meter stick in a photo is 5 centimeters long. What is the scale factor? So you could say 1 meter is 5 centimeters, or we could do and figure out how much a centimeter on the paper is. So we would do 1 meter divided by 5 centimeters, and we would get 0.2. Well, what this means is there are 0.2 meters for every 1 centimeter on the paper, right? 0.2 meters per centimeter. 0.2 meters per centimeter. So your answer would be 0.2 meters per centimeter. That's the conversion factor. Whoops, that's the eraser. Let me redo this. 0.2 meters per centimeter, and that is your conversion factor. Number 7. What was the time interval that the object was moving fastest? Well, it is the one with the steepest slope, which you should notice is right here. So the answer is between 0 and 2 seconds. Question B. Describe the object's motion in words during the interval from 2 to 6 seconds, which is right here. It's a horizontal line that is stopped, or at rest, or something like that. What was the average speed during the entire 10 seconds? Well, average speed is delta x over delta t, which is 40 over 10, so it would be 4 meters per second. And D, describe the motion between 6 and 10 seconds. That motion is constant speed. And question E, how fast was the object going when the clock was reading 8 seconds? Well, that is a point on this line, so we need to find the slope of this line. We know that this point here is 6, 20, and we know that this point here is 10, 40. So we can do m equals y2 minus y1 over x2 minus x1, and we can get 40 minus 20 over 10 minus 6 is 20 over 4, which is 5 meters per second. Okay? So that is how you would do number 7. Number 8, 2 ants race along the top of a Wheaties box. One travels 4.2 centimeters per second, while the other drags at 3.9 centimeters per second. So we have velocity of guy 1 is 4.2, while velocity of guy 2 is 3.9 meters per second. All right? Or sorry, these are centimeters per second. When the first ant crosses the finish line, how far behind is the second ant? The box is 28.1 centimeters long. So we know that the distance this guy is going to travel is 28.1 centimeters. We know that the time it's going to take this guy is the same as the time it's going to take guy 2, because we're really concerned about where they are when 1 crosses the finish line. Well, when 1 crosses the finish line, he's at time t, and then that's when 2 is at a certain point behind him. So we need to figure out what this time is. So V is equal to d over t, so 4.2 equals 28.1 over t, and then solve for t, and you get t is equal to 6.7 seconds. So once you get that, you know this is the time for t2. So we figure out how far this guy went, so we would do 3.9 centimeters per second times 6.7 seconds, and we would get that guy went 26.13 centimeters. But that's not the only thing the question is asking. The question is asking how far behind is the guy, so you would do the distance of the cereal box, 28.1 centimeters, minus the distance at this guy, the position of this guy, 26.13 centimeters, and you would find that he was behind by 1.97 centimeters. Alrighty. Moving on to number 9. First we have to know 2 bees will race to the hive. BA starts 40 meters ahead of BB. I'm just going to call them A and B. A is here, B is here. A is going 13.6 meters per second, and B is going 15 meters per second, and this distance is 40 meters. All right, so we want to know how fast they'll get there. Well, there's two ways to do this. I'll do the first one, for the easiest one first. The first is to figure out their relative velocity. So we're going to find that they have a relative velocity of 1.4 meters per second. And since they have a velocity of 1.4 meters per second, what that means is that they have a distance to cover of 40 meters in that 1.4 seconds. Or, sorry, they have a distance of 40 meters to cover when B is gaining on A by 1.4 meters per second. So we can just divide that by 1.4 and find that it would be 28.6 seconds before BA was caught by BB. The other way to do this is to say that their positions must be the same. So the position of BA must equal the position of BB when they're caught, but BA gets a start. So his distance has a 40 meters there. He gets a head start. And what this means then is that if you solve for the velocity, you would get solve for the distance, 13.6 times t plus 40 equals 15 times t, and if you solve that, you get that answer. So the second question was, how far had BB gone? And that would just be calculating, there's too many B's in this thing, so that would just be the formula V equals D over T. You know, he's going 15 meters per second for 28.6 seconds. So you can solve for D. It should be 15 times 28.6, and I'll let you do that on your own. That is the answer. Alright? If there are any questions, feel free to tweet me, and I will do my best to get back to you.